All right, density is mass per unit volume. So basically things that are more dense than other things for a given volume have more mass, okay? So if we always looked at, say, in chemistry class, what you did is you always looked at a cubic centimeter, right? A cubic centimeter, by the way, is 1 milliliter, right? It's equal to 1 times 10 to the minus 6th cubic meters, right? Which is crazy, right? There's a million milliliters in a cubic meter. But anyway, if you looked at 1 cubic centimeter, this is how many grams it would be. Remember, water is 1 gram, right? And some things are slightly more dense. Mercury, is its specific gravity was 13.6. And in general, the densities in kilograms per cubic meter vary from the ones you knew in chemistry in that they are times 1,000, right? So water is 1.00 times 10 to the third, so it's 1,000, right? Gold is 19.3 thousand kilograms per cubic meter, okay? And I got some demos for you. I'll show you some demos when you get into class. I'm just going to show you how to solve these problems right now. Notice that this symbol is the Greek letter rho. So it's kind of like a P that's sort of leaning over like that. And rho is just mass divided by volume in cubic meters. In chemistry, you did grams per cubic centimeter, which is much more reasonable. But you know, here in physics class, we're not afraid of big numbers, so we do it this way, right? Oh, and then here's a general rule, right? Things that are less dense than things that are less dense than water float in water, right? And so, for example, they don't have any. Oh, wood. Here we go. Wood. There you go. Very large range. Wood can, by the way, be more dense than water, but wood would float on water. It's less dense. Lead would not float on water. But this is interesting. Lead would float on mercury. Where's mercury? There. Lead is actually less dense than mercury. So a chunk of lead would float. A piece of steel, right, would float handily in mercury. Half of it would be exposed almost, right? Okay. That's kind of fun. If only mercury weren't so toxic, it would be a great demonstration for this. All right, let's go to the example here, right? What is the mass of an iron cannonball that is 17 centimeters in diameter, right? This is as hard as it could be. Our radius then is 0.085 meters. I'm just going to go on the record to say that, right? That is, by the way, 0.17 over 2. Let's double check that, right, shall we? 0.17 divided by 2. Yes, my brain is not fried. Okay. And then our volume is going to be 4/3. And these are in the data packet, 4/3 pi r cubed. They actually put area of a circle and volume of a cylinder or a volume of a sphere. And let's just assume that this cannonball is spherical. All right, so 4/3 pi times 0.085 to a third. So 4 divided by 3 times pi times that 0.085 that I just got raised to the third. And that is a very small volume, of course, because remember our volume is cubic meters. So all your volumes of normal objects, like normal things like cannonballs, are going to be small in cubic meter land. This is, by the way, 2.5 liters, right? Because liters, you put the decimal point there, 25724. This is cubic meters, right? And then we want to know the mass, so we will use density as mass divided by volume. It's a cannonball, so it's iron. So I'm going to say that it's 7.8 times 10 to the third, right? Is equal to the mass of this cannonball divided by 0.0025724. All right, so I'm going to go that times 7.8 E3, and I get 20.06. The mass is equal to 20.06. There we go. We have only 2 sig figs, so we'd say 20 decimal point. All right. Try the next problems. I'll solve a few problems here. See if you can solve those. If you can do it without looking at the videos, do that. If you can't, by all means, look at the videos.